My dear viewers, welcome to once again the Future Knowledge Bank. Today I am going to explain you applications of the trigonometry. This is very important chapter after trigonometry, and trigonometry just how to use the ratios and the different kinds of values regarding the formulae and the three identities and supply of the identities we have to discuss in that trigonometry. But applications of trigonometry based on the what you call right angle triangle, how that differently we can apply in the general life. So this kind of introduction I'm giving, and what kind of the things we have to see here, I will show you. First of all, before starting what we call introduction of this applications of trigonometry, first thing we need, what is the angle of elevation? Angle of elevation here. In this case, what angle of elevation means, when we are on the ground is this one. This is we can call as horizontal. Horizontal. The ground is called as horizontal. When we want to see a tower or a building, we have to see on the high row. That means here. This is the way. This is what we call ray of view, where we are viewing upward. We are viewing upward. Above the horizontal, what angle is making, that is called angle of elevation. Above the horizontal, that means above the ground, what angle you are making, that is angle of elevation. And this is the first thing we have to go through in the case of what you call application of trigonometry. Second one is angle of depression. This is the angle of depression, DEPRESSION. Angle of depression. Here, suppose again, same situation, ground should be taken as horizontal. Ground should be taken as horizontal. And now, what is going on now? Here, one interesting matter. When you are seeing below the horizontal line, what angle is making below the horizontal line, that angle is called angle of depression. Here, this is what we call ray of view. This is what we call ray of view. So now, and two things you have to remember. Some hints I am giving how to solve the problems in 12.1 and 12.2 exercises in state syllabus and other things else. First thing is to solve the application of trigonometry. You have to take very seriously. What does that means? First, you have to draw a right angle triangle. First, you have to draw a right angled triangle. Right angled triangle. This is first you have to draw. Second one, represent whatever the data in the given in the question. Represent the data given in the represent the data on triangle. That means in the some point may be given on hypotenuse, some point may be given on adjacent, some point may be given on opposite. So what kind of the data is given, where you have to place, that is the most interesting situation here. And third point is find the relation between known values and unknown values. You have to say that one, find the relations between known values and unknown values. This is actually by using the known values, how to get the unknown values. That is called relation here. Relation in the sense is you take the advantage of the known values and find out the unknown values. And the thing, next fourth hint is to you, choose the correct correct trigonometric ratio. Trigonometric ratio. That means whether you have to take sine cos theta, you have to decide the right system, because for example tan theta means it is a opposite by adjacent. Like that we have to decide which one you have to take according to the data given. We have to consider what kind of ratio we should apply for the problem. So now I am taking the very important problems in the 12.1 exercise. Now, very important problem I am teaching here. First, we can see a tree was broken due to storm, and the broken part bends so that the top of the tree touches the ground by making an angle of 30 degrees with the ground. The distance of the foot of the tree and the top of the tree on the ground is 6 meters. That means this is originally the tree. This is the broken part of the tree. And the broken part of the tree I am taking as x. And original and remaining part of the tree I am taking as h. And whenever this broken part is broken down and touch the ground here, that angle of ray of u is making, the ray of u is making an angle of 30 degrees here. So this tom where it is touching the ground, this part and the base of the tree, what distance we are having? 6 meters. 6 meters having. So is asking what is the total height of the tree. Total height of the tree means h plus x you have to find out here. Now I will explain you with one interesting stick here. Now we can see this is the one big tree. Suppose you think this is the big tree, and because of the storm it is broken. It is broken. And after broken it is touched the ground. This is the way it is touching the ground here. This is the ground. The tree was broken, and you can see this is the ground. This is the remaining part of the tree. Because of the storm this is a broken here. This is what we call, this is the broken part, and this is the remaining part of the tree, and this is the pen which I kept here, that is what ground. So he is asking, and we are seeing that this is the top part is touching the ground here, and remaining part is h, the top part is here. This is the 30 degrees angle it's making. So this is the way we have to think it is. That means this total length is asking, this broken part length and this remaining part length is asking here. So we will go through the sum. And let, in the solution, let the distance, let the distance between the foot of the tree, the foot of the tree, foot of the tree and point of contact, here this is a contact of point of contact of top of the tree, top of the tree. top of the tree on the ground. Top of the tree on the ground is equals to 6 meters. That means this is the foot of the tree. This is the broken part which touch the ground. What distance is making between these two means that means whatever the data given, we are applying on the trigonometry on the triangle, right angle triangle. One data we applied here 6 meters, the distance here, and one another data is height of the remaining part of the tree is taken as x, and the broken part of the tree is taken as remaining part of the tree is taken as h, broken part is taken as x. So you have to find out the both the values now. Now we have to go through. Next step is let length of the remaining length of the remaining part of the tree. Remaining part of the tree is equals to h meters. And next thing is let broken part of the tree, part, this part here, this broken part of the tree, broken part of the tree is equals to x meters. Now angle of elevation, angle made by the broken part of the tree, angle made by the broken part of the tree. This broken part only we got the angle here, so that purpose how much it is, 30 degrees. Okay, then it is time to go for that one. Select the last minute is select the ratio. What ratio I am taking? Tan 30 I am taking. Why I am taking tan 30 I will tell you clearly. Because we having the information of adjacent here. We don't know the opposite, we don't know the hypotenuse. By using the tan is having a relation of what we call opposite by what we call adjacent. Here opposite is what we call h and adjacent is 6. So we having one information here. Here we are having one information, 6 is there, and we have to find out h. We know according to the tan 30, we know the tan 30 value. Here now according to the tan 30 value, we are saying here in this place tan 30 value are taking as 1 by root 3 is the value of tan 30, and then opposite is h and adjacent is 6. Now we will apply for cross multiplication. H into root 3, h root 3, 6 into 1. Here next, therefore h is equals to 6 by root 3. And because of the root 3 point of view, you have to go for what you call rationalization on both the sides. 6 root 3 will get it. Root 3 into root 3, 3 will come, and this will go 2 times, and you will get his 2 root 3 is the answer here. So h is equals to, therefore h is equals to 2 root 3. That means h is nothing but remaining part of the tree. H is nothing but remaining part of the tree. That h we got. Now it is the time to calculate what we call this broken part. This broken part we have to calculate. This remaining part we got h we got here. We have to find out the broken part. After getting the broken part height and remaining part height, if you are adding, total tree height will come. So now here what we call cos 30. Why we are taking cos 30, you know very well. Here what is the sense of the cos 30 means? Is cos is nothing but adjacent by hypotenuse. Adjacent by hypotenuse. So here adjacent ADJ by hypotenuse. Here adjacent is what? Okay, actually we are having 6. Hypotenuse is x. And then what is the cos 30 value? We are taking that purpose. I told already last point. Correct ratios you have to take. Here the tan is a correct ratio. Here cos is correct ratio. Why? Because tan we are taking to get the information of opposite. Cos you are taking because to get the information of hypotenuse. If you are taking tan here, we can't get hypotenuse. If you are taking cos here, we can't get hypotenuse. So which occasion you have to take tan theta, which occasion you have to take a cos theta, that's important scenery here. So cos 30 value is root under root 3 by 2 to 6 by x. So cross multiplication, root 3x is equals to 6 into 2. Therefore, x is equals to 12 by root 3. And you have to go for rationalization over here. 12 root 3 by 3 will come. So 3 will go in 4 times. So 4 root 3 is the length of the broken part of the tree. Length of the broken part of the tree. And here length of the remaining part of the tree is 2 root 3. Now we have to add total. What is now? Total height of the tree is equals to remaining part of the tree, plus broken part of the tree, is equals to, here we are taking 2 root 3 is the remaining part of the tree, broken part of the tree 4 root 3, total we are getting 6 root 3. So 6 root 3 means 6 into 1.732. If you are multiplying, we will get 10.392 meters. This is the total height of the tree. Now here is the sum is there. Length of the shadow of a 15-meter high pole. That means this pole height is 15 meters. And this pole is getting a shadow. This is the shadow. This is the shadow. The shadow, how much length of the shadow is? 15 root 3. Shadow is 15 root 3. Height of the pole is 15 meters. This is 15 root 3 meters. This is 15 meters. Okay. In the morning, the 8 o'clock, the sunlight will be slant only. So morning sun will give the big shadow. So original tree length is different and here is different. Now we'll come back to the what you call the solution here. And what is asking? What is the actually question is at 8 o'clock in the morning? What angle of the sun rays? These are the sun rays. What angle they are making with the ground? What angle that angle is making is the ground we have to find out here. This is the theta we have to find out here. And then now we can see this is the diagram we have to take here, triangle, and this is the 15 meters height of the pole, this is the shadow of the pole. Now information, height of the pole is equals to 15 meters. Next, shadow of the pole. Shadow of the pole is equals to 15 root 3 meters. Next, let the angle of elevation let the angle of elevation be theta. This one we have to go through. Let the angle of elevation is theta. Now we are going to, because we are having, it is why we are taking, which ratio you have to take is important thing here. Which ratio means we are taking the ratio is tan theta. Why can't we take the sin theta? Why can't we take the cos theta? Means tan theta why you are taking means because tan theta relation is opposite by adjacent. So we are having both opposite and adjacent here. Automatically we will get the, so tan theta we have to take the choice. So tan theta means opposite is how much? 15. Adjacent is how much? 15 root 3. So 15 going to be get cancelled. We got 1 by root 3. And now here tan theta means is we got as 1 by root 3. According to that one, what is that? When we'll get the tan theta value is 1 by root 3? When theta is equals to 30 degrees. Theta is equals to 30 degrees. That means tan 30 value is nothing but 1 by root 3. 1 by root 3. So this is the interesting sum to find the angle of elevation. Yes, now next important sum is you want to set up a pole, a height of, that means you want to set up a pole. This is the pole here. This is the pole. You want to erect the pole. Suppose current pole you want to put on in front of your house. When you are keeping the current pole in front of your house, simply we cannot lift the current pole with even 2-3 human beings also. They has to tie 3 ropes on the top of the current pole. Then some people will catch the one rope, some people will catch the another rope, and one people will catch the third rope. 3 ropes are compulsory, otherwise the pole will fall any side. That purpose here you want to set up a pole of height is how much? The pole height is 10 meters. The pole height is 10 meters vertically. Support of 3 ropes. First rope number 1, this one. This is rope number 1. This is rope number 2. This is rope number 3. 3 ropes we are catching on the 3 sides of the different sides of the people. So here angle, what rope that each rope is making an angle is 30 degrees. They has to make angle of compulsory 30 degrees here. So finally what is asking, what should be the length of the rope? So what should be the length of the each rope and 3 ropes also? So we'll find out now. First we'll go for the calculation here. Let height of the pole is equals to 10 meters. Next, length of each rope length of each, let the length of each rope is equals to x meters. We don't know what is the length actually. Now, next thing is angle, angle made by the rope. Rope is making the angle here because we are tied ropes on the three sides with the pole. What angle the rope is making with the help of the pole is 30 degrees. 30 degrees. Now, it is interesting situation here. Now we are taking cos 30 degrees here. Why we are taking cos here is this is the pole we are considering as a base. Pole we are considering as a base. That means pole is considering as a adjacent, and this rope is hypotenuse. This rope is going to be the hypotenuse. I will clearly tell you. This pole is, this is not I'm taking, this is, we are not taking the, what you call, base. Adjacent we are not taking, this one, pole height only we are considering as a adjacent. So then here adjacent by hypotenuse. So hypotenuse we don't know. So that is the reason we are going to be adjacent, already we having 10 meters adjacent, and the pole we calling as x. This is also x, this is also x, this is also x here, because the three ropes we kept there. So here is x is there. Now, according to this one, what is the value of the, what you call, cos 30 means root 3 by 2 is equals to 10x. Now, cross multiplication, which implies root 3 x is equals to 10 into 2. X is equals to 10 into 2 by root 3 is equals to 20 by root 3. 20 by root 3 is the length of the each rope. Now, then we have to find out, easily we got that one, what is the length of the each rope. Now we have to find the length of the three ropes. So total length of the three ropes, total length of the three ropes means we have to take easily one rope length is 20 by root 3. Three rope purpose means 3 into 20 by root 3. Now we got as 60 by root 3 into root 3 by root 3. Now 60 by root 3 is equals to root 3 into root 3, 3 will come, 3 will go here, 20. So 20 root 3 we got here. 20 root 3 means 20 into 1.732. We will get finally 34.64 meters is the length of all three ropes. Length of all the three ropes which we tied, which we took the help to install the pole here. To install the pole, to set up the pole, three ropes help you are taken. So the three ropes length is 34.64. This is the procedure one, and see the steps once again clearly. Height of the pole, 10 meter, length of the each rope, angle made by the each rope with 30 degrees, cos 30 we have to take here. Why? Because we have taken the base as the pole, and so cos 30 is root 3 by 2 is equals to 10x, and x is equals to 20 by 3. We got length of the three ropes. Final calculation we got 34.64 meters. Now you see here another sum. Another sum is an electrician wants to repair electric connection on a pole. Here, one big pole is given. This is the pole which I am showing here now. This is the pole. One big pole is there. You want to do the repair, and on the big pole, in this place, you are having the electrical couplings here. You want to repair. The electrician want to repair on the pole, and height of the pole is actually total height of the pole from here to here, 9 meters. 9 meters. 9 meters is the total height of the pole, and but the electrician, he will use one ladder. He will use one ladder, LADR. That ladder height, he cannot reach the total height of the pole. Total height of the pole is 9 meters. Only ladder we are taking, but ladder we are not taking that up to that range. But here, that ladder can touch the only certain 7.2 meters here. The ladder can touch. This is the 7 here to here. This is what you call 7.2 meters. Above the ladder, 1.8 meters are there. So 1.8 meters height we don't want. So ladder can touch up to 7.2 meters. Total height of the pole is 9 meters. So now ladder is reaching 7.2 mark. Above 7.2 to 9, how much is left? 1.8 meters left. Now, and what is asking in this one? An electrician wants to repair an electrical connection on the pole, a height of 9 meters. He needs to reach 1.8 meters below. 1.8 meters below here. The top of the pole to do the repair work. What should be the length of the ladder? He's asking what will be the length of this ladder. That means he's asking hypotenuse here. Length of the ladder, and he should use when it makes an angle of 60 degrees. It is making an angle of 60 degrees. So now, here length of the ladder we are taking as x. We are considering as x. And what will be the distance between the foot of the ladder and foot of the pole? Foot of the ladder and foot of the pole, this distance also is asking. This is the distance between foot of the pole and foot of the ladder is d. We are calling as d. And the length of the ladder is x. So now it is a time to calculate length of ladder x and the distance between the foot of the ladder and the current pole. And now the step number point of view here, height of the pole. First of all, you have to take height of the pole. Total height of the pole is actually 9 meters. Next, height of the point. Carefully see the steps. Height of the point from the ground. Height of the point from the ground where electrician reaches the pole. Actually, electrician is not reaching the 9 meters pole. Electrician is reaching only the some certain height. What is that one means? 9 minus 1.8 is not reaching, is reaching up to 7.2 meters height of the pole only. There only couplings he has to arrange, he has to repair the things over there. So now, what angle the ladder is making means angle of elevation. Angle of elevation is equals to 60 degrees. Next thing is, let the length of the ladder is equals to x. Then next, distance between foot of the pole and foot of the ladder. Foot of the pole and now the distance between the foot of the pole and the foot of the ladder is we are taking as d. So now immediately we are taking here not cos theta, not tan theta, we are taking sin theta here. Why? Because here we having the information of the hypotenuse, we having the information of the opposite. So that purpose sin theta means opposite by hypotenuse. That is the reason we are taken the ratio as a sin theta here. So sin theta means what is opposite here? 7.2. That much of height only the ladder is reached. And here hypotenuse is x. That means height of the ladder here that we want. And now what is the value of the sin 60 means root 3 by 2. Root 3 by 2 is equals to 7.2 by x here. Now cross multiplication x is equals to 7.2 into 2 by root 3. So here when we are taking here what we call 7.2 into 2 means 14.4 by root 3, and we are going for what you call rationalization root 3 by root 3 here 14 point root 3 by 3 we got here. So now and we will going to be get cancelled here, trial here, and 3 will go in 14 3 times, 4 times I think so, and 12 will be left, and 2.4 means here 6 times, 8 times, 4.8. So x is equals to here what we will get 4.8 root 3. That means the height of the ladder is equals to 4.8 root 3. In that 4.8 root 3 means it is equals to 4.8 into 1.732. 1.732 means we are going to get the after calculation we are going to get here 8.31 meters is the length of the ladder. And comes to the point here, we have to find out now the distance. You have to find out the distance between the foot of the ladder and foot of the pole. So now what do we have to take here? Tan theta. Sin theta is taken for to find the length of the ladder. Now distance purpose we have to take tan theta. Now tan 60 in the sense is here 7.2 by d here. What is the value of the tan 60 here? Root 3. Root 3 is equals to 7.2 d, and d root 3 is equals to 7.2, and d is equals to 7.2 by root 3 here. And then we'll go for rationalization on the both sides. 7.2 into root 3 by 3, and 3 will go here 2 times, and 4. So d is equals to 2.4 root 3, and 2.4 into 1.732, we will get 4.1568 meters. This is the distance what we are. And here, this is a very, very most interesting one. I will put certain names here for this triangle A, B, and C. Why I am keeping the names means because it is explanation is very important for this sum. Here, a boat has to cross a river. Here, river is BC. BC is the river. The boat is started here, and this is the river. It has to. The boat should start from. The boat should start from this place, and it has to reach the sea, the point C, other end. This is the width of the river. It has to go straightly like this. But the water current is not allowing the boat to go like this linear motion. And the water current is pushing the boat, and the boat is going on like this and finally reaching the at this point. Instead of reaching C, it is reaching at A. So because of water current in the villages, people know how this current water current will be. In the cities, we don't know because we didn't see that much of a beautiful water currents here. So now, actually, water current means swimming means even high, beautiful, perfect swimmer also cannot go directly like this. Cannot go directly like this. The water current is too high, so he has to balance like that. It is my personal experience also. Whenever I started nearing the high tide, in the high tide in the river, water current will be very high. If I can challenge with my friends also, I will go this straight means 100% it is impossible. It has to go instead of the BC line, it has to go BA line. And other hand, I will reach here. And what angle I am making here means here 60 degrees angle I am making. 60 degrees angle I am making with this one. And finally, what is asking? A boat has to cross a river. It crosses the river by making an angle of 60 degrees with the bank of the river. This is the end of the river we call bank. Bank of the river due to stream of the river. The stream is very, very high current and it travels a distance of 600 meters. Travels a distance of 600 meters. Actually, it is not 600 meters. The width of the what you call river is not the width of the river is not actually that much good. We have to find out the width of the river, and we have to how much the distance he crossed. We have to know 600 meters. He is tried to swimming. So now here you see, let the width of the river, let the width of the river is equals to x meters. Width of the river is equals to x meters. And angle made by the boat, angle made by the boat, angle made by the boat is equals to 60 degrees. Then distance traveled, by the boat is equals to 600 meters. Actually, it has to cross less than 600. This BC is less than 600, but 600 meters it is crossing. So now 600 meters it has to cross. Now, and now we having the information of hypotenuse, and we have to find out the information of the adjacent. So we have to take the ratio. Correct ratio for this one is a cos 60 is equals to adjacent by hypotenuse here. And here this is adjacent, we don't know, that is x, and hypotenuse, how much distance is all we know, 600 meters. And cos 60 value is 1 by 2. 1 by 2 is x is equals to x by 600. So cross multiplication here, 2x is equals to 600 and x is equals to 600 by 2 and x is equals to 300 meters. So therefore the original the original length the original length of the river is equals to 300 meters. But actually original length of this is 300 meters because of the water current is swimming became double 600 meters. So this is the way, this is a good kind of sum that you are going to face in the final exams. So and tomorrow I'm going to continue the 12.2 very important sums with the part 2 of the what do you call applications of trigonometry. Thank you for watching.